the other day. Don't get too worried if you're like, this is kind of deep stuff, because it is. We're just like getting to the lowest level on some of this stuff. So what we're going to do today is a little bit more review. The only problem I will say with what we're doing today is they use a lot of different and new sign conventions. Not sign conventions, but symbols that we never used last year when we did electron configuration stuff. Okay? I think is this on your note packet that says to not do 75B? Yeah. Okay. So you should remember from physical science the principal quantum number. Do you remember what the principal quantum number or the symbol N represented?
Sine energy, right?
Okay, yeah.
I don't remember much about it, but it kind of works.
Okay, so when I say N of 1, what that represents is the first energy level. And when I say N of 2, you can probably then make the comparison here that I'm referring to the second energy level. When I say N of 3, and do you guys remember how many total energy levels there are? There are 7. If you remember, the periods or the horizontal rows tell us what energy level these guys are in. For example, if I'm talking about potassium, its outer energy level that actually has electrons in it is the 4th. Does that mean it doesn't have the 5th, 6th, and 7th energy level? No, it still has it, it just doesn't have any electrons in it. Does that make sense? Okay, and does this mean that potassium doesn't have any electrons in the 1st, 2nd, and 3rd? No, it definitely has them. It has them full. Okay, so where they're located on the periodic table tells you where their outer electrons are. Right? Now, as the number for N goes up, what can you tell me about things regarding location and energy of a particular electron in the atom? Energy goes up as N goes up. Okay, what could you tell me about location? Okay? As N goes up, you're getting further away from the nucleus. It should make sense, right? The electrons are attracted to the protons in the nucleus. You give it energy, it starts to get a little bit further away. More energy, even further away. More energy, even further away. You give it enough energy, it can leave. Okay? So as N increases, your orbitals become larger. Okay, they become further away. Your electrons spend time further away from the nucleus, and your overall energy is going to increase as N increases. So, this is not new. N of 1, N of 2, N of 3, that should be just reviewed from last year, or 2 years ago for some of you. This is going to be review outside of the symbol. So if you guys remember, we have N of 1 through 7, and then we had sublevels. You guys remember the sublevels? There were 4 of them. What are they? S, P, D, and F. See, so there's some things we gotta remember. S sublevel has how many orbitals? You remember this or not? 1. The P has 3. The D has 1, 3, 5, 7. You remember that? Okay. So S has 1 orbital, P has 3 orbitals, D has 5 orbitals, F has 7 orbitals, and theoretical G has 9 orbitals. Might as well. It's just theoretical. Is that a sneeze?
Yeah.
Now, do you remember how many electrons can fill an orbital? 2. Okay? So, let's add another column here and say max electrons that fill each sublevel. Alright? The P sublevel, what's the max? 6. The F sublevel, how many? Do the math. Okay, and then we got 2, we got 10, correct? You should recall or remember these. Okay, now location on the periodic table. Remember, S sublevels here. Remember this? D sublevels here. P sublevels here. F sublevel is here. Okay? Now, let's count total electrons here. P sublevel. 1, 2, 3, 4, 5, 6. Max. Could I have less than max? Like if I have fluorine, do I have 6 electrons in this P sublevel? How many do I have? 5. What if I'm here? 2. Okay? D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can have a max of 10, but that doesn't mean I will have 10. Depends on the situation, and so forth. Okay, another thing that you might want to remember is the little coffin here. I don't know if you guys remember this.
I remember something about this. I remember a coffin.
Yeah, it was like a,
I think it's like that. 1, 2, 3, 4, 5, 6, 7. Okay, and each of these represent an energy level. N of 1, N of 2, N of 3, N of 4, 5, 6, 7. And this just helped us know which sublevels are in which energy level. I don't know if you guys remember this. Okay? The first energy level can only have the S. Doesn't have anything more than the S sublevel in it. Okay? Second is S and P. Third is S, P, and D. S, P, D, and F, and so forth. Now I'm going kind of fast here, but I feel like you guys grasped this fairly well when we were doing just regular chemistry, that I don't have to spend too much time reviewing. Is it coming back to you a little bit here? Okay.
You have to re-layer, like nobody has
Actually, we're going to go a little bit further and talk about all the exceptions as well.
Okay. It knows that. This 2 lines you had written under.
Yeah, but you won't get it.
Not the same as what we learned.
Yeah, because this has the exceptions.
Oh.
Yeah. There's an exception. There's an exception. We're actually only going to talk about 2 exceptions, even though there's like 15 of them.
Wasn't there one that was like, use numbers, you could talk to one, whatever it was, line with numbers, not this, but something else.
You're not talking about the diagonal one, are you?
Yeah.
We'll do that.
Okay.
Okay. Now, if you remember, you should recall that the third energy level only has S, P, and D. So if I were to ask you this, would you be able to answer it? Max number of electrons in the third energy level. Could you tell me? Go ahead. 18. Everybody, were we able to figure that out? You would look and figure out how many sublevel, what sublevels are in the third energy level. Okay, S, P, and D. Count total orbitals, 1, 3, and 5 for a total of 9. Times 2, 18. I could ask you that on any of these. Okay? Just want to make sure we're good on this. Now, the difficulty that you're going to run into is your book is not going to say, hey, here's the sublevel. It will tell you the quantum angular momentum. So let me explain what I mean. Your book might say, what am I referring to if I say N is 2 and L is 2? That's not possible.
I was like, what?
N is 3, L is 2. What am I referring to?
Level D or level 3.
That's what I'm referring to. The 3D sublevel. Everybody see it? Why did I say this was wrong?
Because there is no D in
There's no D in the second energy level. Yeah, you see what I'm saying? So your book will probably talk more in quantum numbers and not in, hey, here's the sublevel. So we're going to talk about kind of some symbols. N represents energy levels. L represents what? The sublevels. We're going to talk in a sec about ML, which represents orbitals in your sublevels. And MS represents spin in the orbitals. Okay, so we're going to have a variety of different quantum numbers that we're going to have to understand. Do we know energy levels? Do we know sublevels? Do we know how many orbitals are in each sublevel? And do we know Hund's rule that you can only have opposite spins in orbitals? Do you remember that? You remember doing orbital notation?
Yeah.
And when we did 1s, we had to have one up arrow and one down arrow. And the reason why that was because we have to have opposite spins so that we have opposite magnetism, so that it doesn't, for whatever reason, cause chaos within the atom. Okay? If you've got a north side, you gotta have a south side from an electrical and magnetic standpoint. Okay, even to this point, I don't have a great understanding on that, just knowing that there's some sort of magnetic electrical issue that they have to be opposite, otherwise they would repel in some way.
I really wonder if I ever get technology advanced enough to change the spin and see what would happen.
I'm sure that, I'm sure anything we've thought they've tried, but you don't know. Okay, so this is what I was referring to, the magnetic quantum number, that would be ML, is referring to the orientation of the orbitals. So I want you guys to open up your books to page 304. There's a table on here that is pretty helpful. That kind of has all of the things on it except for MS. Okay? So what they're saying is, if you look at this table, if I'm saying N is 2, L could be one of two things. L could be 0, and L could be 1. Why? Because there's S and P. Okay? And then they said ML can be -1, 0, and 1. What did I say ML represents?
Orbitals?
Orbitals. And I should say ML for the L of 1 is -1, 0, and 1, and for that it's just 0. What am I referring to? It has 1 orbital. It has 3 orbitals. Because isn't this P and isn't this S? So what this is saying is each P orbital is not oriented the same. We've got a P orbital on the x-axis, we have a P orbital on the y-axis, we have a P orbital on the z-axis. So this might represent the x-axis, this might represent the y-axis, and this might represent the z-axis. I don't know which represents which, but what they're saying is, in the P sublevel, I have 3 orbitals that are all oriented differently. Does that make sense, everyone? So let me say, if I was doing N of 3. I would have L of 0 represents the S, L of 1 represents the P, L of 2 represents the D. Well, we know that S has one orbital, so it only has one orientation. We're saying that's orientation 0. This has 3 orbitals, so it has 3 orientations. So we're saying negative 1, 0, and 1. D has how many orbitals? 5. So it would have orientations of negative 2, negative 1, 0, 1, and 2. Does that make sense? Okay. It's just a way of representing the things we've talked about with numbers and symbols. So, is this possible? N of 3, L of 1, ML of negative 2. Is this possible? I see one correct head shake answer. You were right. Why is it not possible?
There's only 3 orbitals in P.
Yeah, this is representing the P sublevel. And this would be assuming you would have the 4th and the 5th orientations. But there's only 3 orientations within the P sublevel. Do you see what I can start doing here? Your quiz and your test questions are going to be saying, hey, is this possible? Is this not possible? So you need to know what the N represents, what the L represents, what the ML represents. Okay? Everyone good? Flip in your book and your page. Okay, flip to 307. So if we're looking at these, let's say, what do you think these purple sublevels represent? The D. How'd you know that?
Label?
Okay, and the fact that there are 5 of them, then shouldn't that be a giveaway?
Yeah.
So let's say this orientation here, as one I'm pointing, look up here. Let's say this represents the negative 2 orientation. This represents the negative 1 orientation. This represents the 0 orientation. This is the 1 orientation, and this is the 2 orientation. Alright, you guys are look like deer in the headlights. Look like this is the most complicated thing you've ever seen in your entire life. It's not, is it?
Is it always supposed to be like that?
What do you mean?
Negative
So the
1?
first one is
It's just a representation of orientation. That's what they
It
chose.
used to be like
P,
5, 2,
so you're gonna
It'll always be starting from 0, working your way right and left on a number line.
so it could be like 5.
See, basically just call it
5.
You can call it whatever you want, but stay within the parameters that they're using.
Yes, there's 1.
That's what I'm saying. Does that make sense?
P only has
Like they could have said 5 is one orientation, 2 is another orientation, but that doesn't make very much. That would be too. I don't know. It wouldn't be organized very well. I don't think. Does that make sense? Like they could have chose that, but they didn't choose that. They chose specifically a nice number line scale. Okay. And then the last one is going to be your spins. Actually, let's skip this here. Let's just talk about this. So we said N represents energy levels, L represents the sublevels, S, P, D, and F. ML represents how many orbitals, or the orientation of those orbitals. And you couldn't get any higher than -3 or +3 without going into the theoretical. Why do I say that?
It's 7.
The max that we know of that to be true is 7. So I could have -3, -2, -1, 0, 1, 2, 3. But this would be only if I was referring to what sublevel? F, or an L of 3. Now notice something. Your ML will never be greater than your L. So if I have an L of 2, I cannot have an ML of 3 or -3. Because this represents D D can only have 5 orientations, you're not going to get to -3 or +3. Okay? Next is your spins. This is just referring to what I was talking about earlier, that each sublevel has to have an opposite orientation spin-wise. So, each orbital will either have a -1/2 spin or a +1/2 spin. Okay? Cannot be, this would represent maybe the up arrow, and this would represent the down arrow. Okay, is this possible? Or maybe I should say this, what does, yeah. Let's see, let's go N of 4. L of 3. ML of -1. MS +1/2. Is that possible? Yep. This. This is referring to the 4th energy level. This is referring to the F sublevel. Is the F sublevel possible in the 4th energy level? Yep. This is referring to, it's like one of the orientations. Now, do we know what orientation that is? No. What would not be okay is if I did -4. Okay, but anything, when I'm talking an L of 3, anything's fair game, plus or minus 3. Anything below that, not anything above it. Okay? Maybe I should say plus or minus, what, greater than 3? I don't know. Probably just confusing me more. What was that? So it'd be like 3, it's gotta be less than, or like, yeah, greater than or equal to -3, something like that. Is that right? That seems right.
No, it has to be
Less than 3.
Has to be less than
Where? Yes, less
Um,
It's less than 3, greater than -3.
So X has to be, this is gotta be flipped.
Yeah.
You just wrote this. You can't write that.
So
Isn't X has to be greater than -3?
And greater than 3.
So you
-3.
No,
You
the
change
first one you
change the negatives
Just flip the sign. On the first one.
on both of them.
Whatever, you know what I'm saying.
Is
And the MS doesn't
It
like.
has to be within the range of -3 to 3 on a number line. Cannot be outside that.
why is it 1?
So this is saying it's one of the spins.
So as long as that's 1/2 and
It's-
-1/2.
Yeah, as long as it's 1/2 or -1/2. This is what we referring to one electron in the in a specific F sublevel in a specific or orbital orientation. Okay, it cannot be like plus 1/4 or plus 1. There's no such thing as that.
Oh, that's why you told us not to do something like that. It's possible.
Oh, and I don't know why I did that. You just say no. I don't know. Okay? It's kind of a lot. I would get familiar with these. What they mean. Because I think you guys are all good on energy levels, what the sublevels are, how many orbitals there are, and the fact that you have to have opposite spins. I think you're good on all 4 of those things. You just need to connect them to the quantum numbers. Right?
Yeah, if you ignore that.